Record. All right. So the next topic, so I think we're recording now. So the next topic we're going to cover, so we've talked about, as I said, the history of system administration, and Unix itself. Now we're going to talk about the philosophy, I should call it. Okay, so this is going to be, uh, let's call it the UNIX way. And what does that mean, essentially? So the UNIX way is basically how they approach to what is the approach to the design of the Unix operating system, right? Like in one word, what is it? And basically what they say is that files are central. The files are central to Unix. Does that make sense? So one way of thinking about it is that in Linux or Unix, and I'll use the term Unix and Linux interchangeably at this point, right? But because I've given you the history, so you understand the context now of what it is, right? But essentially what this means is that oops, everything in Linux is a file. Do you see that, guys? So everything in Linux is a file. And essentially it's a text file, right? So that's, you have in Windows, actually, I would say there's a lot of files that are binary files, that are things like that are not clear, but everything in Linux is a file. Configuration files are files. Devices are files. Directories themselves are files. They're just basically files that list everything that's contained in them and the path and things like that. So everything in Linux is essentially a file. Basically, also, we know that Linux has a hierarchical tree structure directory organization known as the file system. So we have the file system, and it's basically a directory, and it's central to Linux. So directory of files, basically. Okay. So, and as we established, the base of the tree is the root directory, which is the /, right? So, the root of the file system is this symbol here, the /. Okay, so that's really important. So again, these notes you'll have on the GitHub. So once you have this idea of files, then basically you for security reasons, so you want everything to be secure, so you create this idea of access control and file ownership, right? So because you have files that are the central thing of Linux, then you want to have ownership of the files and who has access to the files. And that's one of the key thing to understand in security is access control. Right. So I would say that, let's key ideas of security. So let's say like security, A is file ownership. And B, access control. Right. So if you're talking about Linux security, these are the key ingredients. And it's actually really interesting because everything works except sometimes. So then basically an exception has to be created, to kind of get around this access control, right? But you have file ownership and access control, which are central. So let's talk about ownership a bit. So ownership. Okay. So in Linux, files have two owners. Say ownership. In Linux, files have two owners. And I need to bring up actually the virtual machine. So forgot to turn it. All right, so we're going to start going through these materials and we're going to start looking at some of the commands, as I said, because that's really, what we want to. Bring up the virtual machine here. So we're just going to pick a file somewhere, right? And kind of illustrate this idea. So we're going to open up the terminal again. To do clear, ls-l. I'm going to navigate to the desktop. Clear. And should be in spring 2025. Okay. All right. So any file is fine. So we've got files here. And then I'm talking about having two owners, right? So I have here, the owner, like the one single user, and then a group owner as well. Does that make sense? So that's what I mean. So I'll just grab this as an example and notice whether it's a directory or a file, you have the same thing, but I'll grab this as an example of what I mean. It'll copy. So in Linux, files have two owners, which are, we'll do user and group. Okay. And then we can do that. So for example, something like that, right? So we have here the user and the, okay. So that's kind of the idea. Any questions so far? Pretty easy, right? And the user and the group are actually independent. Every time you create, an account or a file, you'll have to create a user and a group. So let's take a look at the following. All right, so let's think of a scenario here, a case. So suppose Smith, who is in the chem group, needs access to some files usually used by the physics, right? So two departments maybe. How do you give her access? That's the central problem that we need to solve, right? So what do? Do you make copies of the files? Do you make files world readable? Or do you make Smith a member of the physics group? Do you see that? So that's kind of in essence how this works. So let's look at an example. So we have Smith uh, is in the chem group. Chem group, and it needs and she Smith needs access to some files or a file usually in the physics group. So Smith needs access to file in the physics group, right? So then what do? How do you give her access? Give her access, right? And so obviously, it has to do with security. Maybe there's some sensitive information in there or whatever it is, right? So what are the options? A, or oops, A, you have make copies of the files. I mean, you can do that, but that's probably not like how you would want things to work, right? You don't want to create multiple copies and then maybe that file becomes modified and people don't know what's going on. It's not centralized. So make copies of the file may not be the solution. Make the files word readable. What's the problem with that? Yeah, go ahead. They don't need to be, right? So exactly. So you don't want to, we could in Linux do that because we do have the option in access control, but that may not be what we want, right? So that's the whole point that you need to master, right? To be efficient. So that's why the group exists. So the group exists. So then, well, if the file is owned by Bob, okay, only Bob can see it, but also the file belongs to this group, the physics group. So then what do you do if Smith belongs to the chem group? Well, Smith could also belong to the other group. So you just add her to that group. And that file can be viewed, let's say, by anyone in that group. Does that make sense? That's the essence of how this works. Do you have a question? Pardon?
I do, but you may talk.
Okay. Yeah, so anyway, so this is just an example to illustrate what groups do, all right? So again, we're talking about this little field here, right? So maybe I can just write this as the file belongs to what group? Yeah, physics. So physics, like that, right? So then basically that's the idea. And so the solution here, preferred solution, make Smith a member of the physics group. So that is one of the central, and I'll say this one. This is one of the essential points in access control in Linux. Okay, these permissions. So when we go back to the virtual machine, that's what all this information is about. We're saying, okay, this is the group, and this group has essentially these flags that indicate what permissions are given, right, to members of the group. They can read, write, and execute. So if let's say this was physics and Smith was added to that group, she can actually edit, run it, and so on. Got it? All right. All right, so you guys know the ls-l command because this is the one that I'm using. So sometimes you may just type L and the ls, sorry, and that just lists the files, but ls-l gives you actually the information that you want to look at about the files, ownership, and access control, essentially. All right, so now we're going to look at two commands. One of those was in the history that I mentioned from the 1971. We're going to look at chown and chgroup. All right, so these are the commands. So here, some commands basically. So chown and chgrp. Okay, so let me get the changes. All right, so there's the information that we talked about. All right, so let's go back to the virtual machine now, and let's think about this one. So Commands is ch own. Okay. So for instance, I have a file. I'm going to create a file here. Nano. I'm going to do touch example 1.txt. Okay. All right. So here I have it. It's empty and it's owned by seed, but both for user and group. All right. So now let's think about changing the ownership of this file. So I think I have an account in here called dummy2, which we see all the time, but let's try to change file ownership. All right. So I'm going to do ch own. New owner, so let's say dummy2, and then the name of the file, example1.txt. Operation not permitted, changing the ownership. Okay, let's try. Go. What happened? Yeah, go ahead, please. Sorry. Yeah, I was going to explain that. So, yeah. So what was the outcome, right? Did you guys see I was able to change from C to dummy2? Does that make sense? So that was my objective. So what happened was initially, and I have an example that I think should be clear, I tried it without sudo. So if you remember the first week, I introduced that command, super user. It basically just means that if you are in, and we've talked about groups also, right? So there's a group called sudoers in Linux. All right, if you're a member of that group, essentially you can escalate up to be a system administrator and be root almost. Essentially, you have all the powers of root, but still under your account. Okay, so that's a key idea. So imagine here that seed is one student and dummy2 is another student. And seed did their homework in this server and dummy2 didn't do their homework, right? So what happened here is that dummy2 maybe wanted to access the file, but didn't have the permission to do it. You see that? Only a root administrator, let's say the teacher, could allow one account to look at the file of the other. So that's kind of what happened here, right? So when seed tried to change the ownership, they were not allowed to do that, right? So it said permission denied. You can see that operation not permitted, changing ownership because that file, had a different owner. That's the access control. But when I use the sudo command in front of it here, because the seed account is a member of the sudoers group, then I effectively can escalate up my privileges and then I can perform that operation and change the ownership of the file to be dummy2. Does that make sense, guys? So that's a key concept, again, in access control, basically. Did I answer your question? Yeah. Yeah, so that shows us a lot of things, right? So it shows us groups and the concept of group. It shows us sudo and the concept of sudo. It talks about access control, and we also look at the command for changing ownership. Okay. So now so we've done ownership. Now, ownership can also be done recursively, like if you have several files in a folder. So now I'm going to oops, sorry. I'm going to do that. So let's see if I can down. All right, so in here I have, oops. Yep, so I'm going to create a folder, mkdir. Oh yeah, I need to give it a name. So example ch own. All right, so we create this folder. We're going to now navigate into that folder by typing cd. Okay, and then I'm going to create maybe like 2, 3 files in here. Okay, so what I want to do is I want to change the ownership, but of an entire directory tree. So this would apply even if you have folders inside it and files, but I'm not going to do all that. I'm just going to demo it for a few files. So I'm going to do touch test1.txt, touch test2.txt, touch test3.txt. Right, so I'm adding 3 files in there. So if I do ls-l, I have 3 files. Remember pwd, it shows me that I'm an example chown. And if I want to navigate back out of this, what was the command for that? cd dot 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 dot. So remember, dot means current work. It's not just like magic, right? It has a meaning. So 1 dot means current working directory. 2 dots means the parent of the current working directory. So you're saying, I want to go to the parent of the current working directory. You press that pwd, you can see that you're like 1 level up in the directory tree. Make sense? These are important concepts that seem like pretty trivial, but they're actually, there's meaning behind. All right, so now if I do ls-l, you can see I can see my folder there. Example chown, it has 3 files. They were owned by seed. Clear. All right, so now let's attempt. We may need to change the ownership of an entire directory tree. So let's say that you had an account, an employee, and they had a user and they had their own directory. They had a whole bunch of files, and you just want to, they left, and the files are sensitive, so you want to back them up or restrict them or something. So one thing you can do is just change the ownership to root. If you do that, and all those files are owned by root now, then basically they are restricted. Do you see that? So security mechanism. All right, so let's do that. So let's try it anyway. So I'm going to do chown, and I'm going to do -r for recursive. So that means it should apply hopefully to everything in the folder. I'm going to change it to dummy2, or if you don't have dummy2 yet, just change it to root. And then the folder is example. Ph.D. All right, so hit enter, operation not permitted. Why? Sudo, right? Sudo. Again, sudo is very powerful, but don't overuse it, right? That's why it's key to understand these things, because if you go, let's say at work or something, and you're always using sudo, yes, sometimes it helps you out, but sometimes you're actually going to insert new problems. So you really want to understand when you should actually use it. You see what I'm saying? Because you may actually lock up files when you're using sudo a lot, because it just changes the ownership to root. And then when other things try to access the files, they won't be able to. So you just want to be like careful with it. And my batteries. All right. So sudo. Okay, no errors apparently. Let's take a look at example chown. It does say dummy2 here now. Let's go in it. So cd sample chown clear. Whoops, ls-l. And you can see all the files in there have been modified. So the ownership of them has been modified. So that's yet another example of access control. That's security, right? So that's security of the operating system. So remember, we're talking about the philosophy of Linux and essentially the file system. Everything is a file. Access control. That's the key, and permissions, I should say, and so on. Okay. Later on, we're going to look at set UID, possibly this week. So, it's another mechanism related to all of this. All right. We can also change both user and group. Okay. So we can change that. So in this example, I'm going to use it for, I guess I can use it for the recursive example. So I'm going to do cd dot clear ls dash l. And I'm going to repeat my command. If you look over here, that one, but I also want to change the group. So then you can try something like colon, because there's an account called dummy2, there's a group called dummy2. Right? So then you just say dummy2, just like that. So we would want to change the user owner to be dummy2 and the group owner to be dummy2. Because we were using sudo, it should work. Also, sudo persists for a while. So maybe at this point, we could have run the command without sudo, given that we would be sudo for a little while. And later on, we need to talk about how that works also with, it ties back to ID. So, my ID is a seat. My current account that I'm logged in as is 1000. But as we're going to learn later, we have the actual ID and the effective ID for every account. So that's really important to understand how this works. Oh, so let's see. So we ran the command, I believe. So let's check. Yeah, you can see now at the high level, you can see it's been changed. And both user and group have now been modified. Any questions? Yeah, go ahead. You could probably do it if you do a full path. You know what I mean? So, yeah, so full path of this would be with PWD. Yeah, actually, this is the full path. So I can then, I'll show you, do the following. So because this folder is, if I do this like this, actually. Yeah, see, I'm tabbing and it's not working because this is not in here. So no such file of directory, because this is the relative path, but we need the full path. So what I can do is do that. That's the full path. So now it's going to know, okay, I'm going to go to the root, home, C, desktop, and then although this was already done, it should work. But I guess I can change it back to C. See that? So let's change this one back to C. And if I start doing a lot of this, I'm going to break this. But yeah, but see that? So I just did it. So it took it because it's the full path of it. So if I do ls dash l, you can see now it has worked. So you can do this. If you don't put that root in there, this little thing here, it's gonna still look for this inside the folder. You have to put the root and the full path for it to know how to look. Make sense? All right. Yeah, so pretty straightforward stuff with the commands. So we've done ch group. All right, now we're going to talk about the flags, basically, which are called the file modes. Okay, so the little flags. So let me go back to the notes over here. So this is, yeah, commands. I'm going to change this to access control. So access control. Access control. Control. So we talked about ch own and ch group. The other thing we're going to talk about is the file modes. File modes. And these are the file protection flags, basically. File protection flags. Okay, and so essentially we have three types of access. We have three types of access, which are read, write, and execute. So read, W for write, and X for execute. We actually have one more, which is a special case, which is S. So I'll say for special case. S, which is set UID. Okay, set UID, and this is special. It's kind of complex to understand, so we'll have to really focus on that. But these are the file modes that we have available in access control. All right, so let's go back to the VM. Have that there. Okay, so we're back here. So essentially, these parameters, right? So you have to understand the first is the indication, whether it's a link, whether it's a file, whether it's a directory. Then now you guys understand that this means the user, and then this means the group. So basically the permissions or file modes associated with this account, or these three, I should say, these three flags here are associated with this account. So they basically say what that account can do with that file. It could be that that account can only read the file, right? But they can't write or execute. The next three permissions, which are these, are associated with this part of the line, which is the group account, as you guys have learned. So just by looking at this, you guys can see that the group is not allowed to execute the file. Okay. And then the last three, which are these, essentially say what everyone else can do with the file. So basically the user in the group can read and write, but everyone else can only read, which makes sense. It's kind of like the default behavior. There are some files that are really locked down. So for instance, for the cuckoo's egg, you guys need to understand about etc and passwd files. So let's take a look at those. So what did we say about the etc folder? And this is actually a funny story. So let me actually go to CD in the Linux world. They wrote a book, right? So about Unix or Linux, and they sent it to the publishers. And the publishers took the book and basically, I don't know, they did like a replace something, and they replaced the etc throughout the book with and so on. So essentially, what the book read in a lot of passages was, does that make sense? It's kind of a nerd joke, but anyway. So, but this is a true story, right? So when this first happened, because really this was, this was etc, which, it's just why it was etc. Ask, Ken Thompson and Dennis Ritchie, right? So they're the ones that created the operating system following the philosophy, as I've given you the history of it. But anyway, let's go to the etc folder. Just like that. So we're there. Clear ls-l. So there's a lot of files in here that are related to configuration. So this is, at the center of the philosophy of Linux, that everything is a file, access control, ownership, right? What do you notice about all these files? Like what's one thing that you can tell me about most of these files here? Huh? They're all owned by root, exactly, right? So that tells you something. Serious access control going on there. Some of them will have like another group, like this one has another group, probably because that group needs access to that file. Now in here, we should have the passwd file. So I can try to do ls-l passwd. There it is. And the shadow file should also be in here. Let me do ls-l shadow. There they are. Right, so these are two files that are really important because they are everything that has to do with the accounts on this operating system. Okay, so as I think I said last week, passwd is where every line in that file is a user account. So it's got all the information on the account, but the passwords are not there. The passwords are actually stored in the shadow file. So, and they're not, obviously they're encrypted. So what you have in there is the hash of the file. If you look, the the owner of passwd is root, and the group is also root. But for the shadow, you have even more restrictions, right? So you have a little bit more restriction. The shadow group has fewer users in it. And notice the permissions here, root can read and write. And pretty much the group and anyone else in the world can read that file, okay? But the shadow file, according to this, is owned by root, right? And it also belongs to the shadow group. And root can read and write. The group can read, but it says here, no one else can read the file. Do you guys see that? Like everyone else in the world. Okay, so we are seed, we're not root. So I'm gonna do cat, which is a command I can use to view, or nano. Use nano shadow. Oops. Okay, so I'm unable. Let's do cat. Permission denied. Do you guys see that? So I am not able even to read the file. So what can I do to read the file? Use sudo, right? So if I use sudo, then I become like a system administrator. I become like a root user. So then exactly. So I'm going to use sudo here. And now I can see the file. And what's in here basically, so if we look for the seed account, well, we have dummy, and you can see here we have the hash, password. We also have a few parameters after, these colons are just separators, and they just indicate like policy things, like how often should you change the password and things like that. So that's what that means. And then seed should be here. So you can see seed, and here's the password. If you change even one character of this, you're going to mess up everything. You won't be able to log in. But you would have to have sudo privileges to do it. So if you nano this, for instance, so be careful when you play with this file. But if you do nano, so let's do ls-l. ls-l shadow. Right, so you can see it there. If I do nano shadow, it's not letting me. Sudo nano shadow. You now have access to this file. If you write anything in here to your account, you're gonna mess things up. Make sense? So be very careful with that when you deal with this file. Also, we can do the same for the passwd file. See, now you have access to all the accounts and you can modify them because now you are an administrator. So if you go to the seat account here and doing things like deleting this, you no longer have a terminal to log in. So be careful with that. Make sense? So this is the essence of everything is a file, everything is access control. And if you have an administrator privileges, I mean, you could literally like shut down an entire operation that has Linux just by coming into these things, putting a number or something in a lot of these, shut down. Okay. Because no one will be able to log in, etc. So it's highly, you have to be careful. All right, great. So hopefully that's making sense. Any questions about access? Yeah, please. What kind of errors? Yeah, the one, so to me, okay, so that's a good question. So I would say that in sysadmin, whenever you have a problem, it's probably a permissions issue. Do you know what I mean? So like you're configuring something, you're setting something up, it's not working because access control is so restrictive, it's very likely that it's a permissions issue. So then you have to figure out who is supposed to have access to this, who is supposed to have permission. So what I've noticed sometimes is you're configuring a program, but you're overusing sudo. You're like constantly sudo this, sudo that, sudo. And so what may happen is files that get installed are root owned. And then there's and the group is also root or something. And then some other program, some other account needs to access that file, but they're not in the group and they're not sudoers. And so they don't have access to the file and it breaks. You see what I'm saying? So for instance, let me give you an example. It's a good question. So passwd actually is a good example. Passwd. So it is root owned, but this permission says that everyone can read it, right? But so you have another account that is not sudoer, right? Just a normal account. So they wouldn't be able to, and if this wasn't an R, then they would not have access to read the file. And because you're using sudo all the time, you could create a situation like that. So it needs to be like create more. Yeah, you create more restriction because root is supposed to be a higher, more secure account. So the shell also is smart. And it says, okay, they're using root. So I'm going to lock this down because it assumes a higher privilege. Yeah. Do you see what I'm saying? Yeah. So that's one of the issues the main issue that can happen with you overusing sudo. Great. Great question. All right. Anyone else, guys? Anything else? Yeah. So my suggestion is because I do see students all that just sudo everything, and you can create errors like that or problems like that it's not clear what it is, and because you have to really understand and always look at the permissions. That's why I suggest whenever you're in a folder, just always do that. Well, this is a big one. Always look at the files, get a sense of what's going on, basically. Okay. All right, so let's see where we are. Oh, I'm in root. Okay. All right, so I'm in root. You can see I'm here in root /. We're talking about access control. So we talked about the basic classes also. So if we do cd tc ls-l passwd, right? So we talked about these are called the user, the group, and other, actually. So they have a designation. So let me actually do that in the in the, because we're going to now change permissions, right? So that's the next thing we're going to try to do. So I'm going to add this here in the notes. And I'm just going to say this is access classes. Access classes, yeah. So we're going to change that. So there's 3 access classes, which is going to be user, and that's denoted by a U. And the U is significant because this is going to be like the flag in the command that we're going to need to use. Number 2 is going to be group. And that's going to be a G. And you can also do this with numbers, as we will see later. And then finally, other with an O. Okay, so we're going to create a file basically in the folder and just play with the permissions of it. So this should be an O. Okay. So all other users essentially. So the syntax for this before we do it, and remember when I do this, I just mean the shell terminal. So we're going to learn the command chmod, which you saw it's been around since like the 70s when Unix was first created. And then you select the access mode. So for instance, U, which means the user, and then you're going to add or remove a permission by using a plus or a minus. So in this case, I'm going to do a plus, and then I'm going to say, for instance, write permission. So U plus W of some file, file1.txt. Does that make sense? So that's the syntax that we're going to use for our next example. Right, so let me commit those changes. Oh, it did. I guess it interprets this symbol. So I'm going to use the $sign. All right, yeah. So let's go back to the virtual machine now. I'm going to do clear here. Actually, I'm going to go to the desktop. So let me go to /home, clear, ls-l, and then I'm going to go to seed. And then I know there's a desktop in there. So I'm back in my desktop, clear, ls-l. And I'm going to go back to the spring 2025. So that's ITS 372 spring 2025, right? So I'm back here. And yeah, let's go into example chown. We can use those files. So that's clear. So if you remember, I have 3 files here. They're owned by dummy2. Okay. So we're going to try to change permissions and just see what happens, right? So we've got, let's take the first one, test1, RW, RWR. So how does that work? So I'm going to do chmod. And remember, that's not my file, but I am in the seed group. So I'm going to do U plus W. Oops. U plus W. So what this means is I'm going to look at these 3, right? Because that's the access mode for user. And I'm saying that I want to add the write permission. Well, actually, it already has the write permission. So let's add the X permission for execute, which is, sorry, that one. Does that make sense? So it means that the user can now execute the file. By default, execute is not enabled, and you can think almost like in Windows, right? An exe. What do we know about exes? Don't double click on unknown exes, right? Because it could be what, like malware, similar idea. So you don't want to essentially do it. Did you have a question? More than one what? You can do, I'll show you in a minute how you can change all of them at once. But we have to learn an encoding mechanism with numbers. But we'll do that in a second. Okay. So that's a good question. But let's do these this individual one is so that you don't have to do the math in your head. Okay, so I'm gonna take test one, and I'm going to make it executable. So, okay, it's not permitting me to do this. All right, so then I'm going to have to do sudo. Okay, so that worked, ls-l, and you can see I have now, do you guys see that? I have now been able to do that. Any questions? So, and notice the color changes to green also. Let's say I want to remove the write permission from the group, then for that same file. So then we set that the access mode is G, and we're going to remove, and it's going to be the W. Right? Do you see that? So we run it, hit clear, ls-l, and you can see that we have now removed the W flag from it. And that's essentially how it works. Let's say that we want to write the other flag here. Sorry. Yeah, that one there. We want to make it into a W for that file. So we would do O. That's O. And we're going to add. And it's going to be W, basically. Okay. So now we do ls-l. And if you guys look, W. And this is actually, you're changing the permissions of this, essentially. Does that make sense? Any questions? This is really important. Okay. So you'll get a lot of probably questions like this on the exam of changing permissions, etc. All right, now to answer your question, what if you want to change several parameters at the same time, right? So there is a way to do that, and it's called specifying numeric file modes, okay? So let's go over here. And I think I have that in the PDF, so I'll have to revert to that. Let's go back to Brightspace, where your materials are provided. We're going to click on the PDF that I gave. A lot of what I've said today is in here. So there it is. So this is the numeric file modes, and it's better to understand it just using an example. Okay. So once again, so your goal is what? You want to change multiple parameters at the same time, right? So what you want to do essentially is you have the modes like this, say read, write, execute, read, execute, and just read, right? This is what you have, but you want to change it to something else. So you essentially encode it to the way you want it to be. Do you see that? So let's say that you only had read available and all the other ones were the dash, but you want to convert the file to have an access mode that looks like this. So then what you would do is you would basically say chmod 754 and the file. Do you guys see that? So you wouldn't do the U plus X and all that because that's more individual. Instead, you'd have to just give it a number. It works like that. But you just have to know how to do this math so that you can, whatever you want it to look like, right? You write it down and then do the math to figure out the number that gets you that final access. Do you guys see that? And we'll do an example, but that's essentially the idea. So this little table provides how to do this. Okay, so as you can see, basically what you need to do is you encode this in a binary way. So you're going to say, okay, if I want that flag on, then it's a 1. And if I want that flag off, then it's going to be a 0. So essentially 1 1 1 0 1 1 0 0. Right? So that's what you need to do. So you want this, and then after that, you just are going to convert it to a numeric. So using basically what you learn about binary conversions, right? You guys know how to convert binary to decimal and so on, same idea. So in this case, you know that it's going to be essentially 2 to the 0 times 1, 2 to the 1 times 1, 2 to the 2 times 1, and then that gives you 4 plus 2 plus 1, right? Which is going to be 7. You see that? Then you do for the next one. So it's going to be, again, 2 to the 0, 2 to the 1, 2 to the 2, but it's multiplied by the binary. So here it's going to be 2 to the 0 times 1, okay, which is 1, 2 to the 1 times 0, which is 0, and 2 to the 2, which is 4, times 1, which is 4. So essentially then 4 plus 1 is 5, and you have that there. And then for the final one, it's 2 to the 0 times 0 is 0, 2 to the 1 times 0 is 0, but 2 to the 2 times 1 is 4. And that's how you arrive at 750. Got it? So essentially just do your binary to decimal conversion following this format where you select the binary. So this is how you can do multiple at once, because you just have to encode it this way. Any questions on this one, guys? Does it make sense? All right, great. So I'm not seeing any questions, so perfect. So yeah, so this is pretty fun thing. So we can try this out if you'd like. So we can go back to the virtual machine and take a look at it. So I have ls-l. So for instance, I'll give you a little problem. Let's do actually a little quiz, right? So just take out a sheet of paper, right? And just write down the command that you would use to convert test one so that all of these are populated. So you have read, write, execute, read, write, execute, read, write, execute. What would you do? What would be the command? Should be able to do it, right? Don't worry, these just count as participation, but it's just a little thing you can do. And I'll, pardon? Yeah, test one, yeah. Just either one, just convert. So again, the problem is make every single one be, so let me write it like this. So I'm gonna copy this, right? And I'm gonna go to the GitHub. And I'm gonna write quiz here. With using numeric access modes, convert from this to this. And I'm going to change. So here, see, read, write, execute. So now read, write, execute, read, write, execute. Do you see that? So that's it. So you just have to do that. So what do you need to give me? You need, your answer should look like this. Your answer should look like this. So it's going to be what? I'm going to use the $sign, chmod, some number, right? File, oh, sorry, test one, right? No, doesn't compute. Oh yeah, I leave that to you. That's figure it out. But what I'm looking for is this number. Let's say, I don't know, 315. I don't know, right? But how do you arrive at that number? I just showed you the methodology, right? Any questions? Everyone understand what you need to do? You can do this by hand, and I'll put up this is in your GitHub, in your Brightspace. So what I'm asking is read, write, execute. So you already have that solution. Read, write, execute. So this needs to be a W. Read, write, execute. This needs to be a W and X. So using this methodology, give me the number that goes there. Okay. All right. So you have the rest of the until 1:40 to finish, or if you've done it already. And so I'll stop the recording here.